This lesson is on vector valued functions. First, vector value functions are parametric. They're going to be defined in terms of t. Linear combination standard unit vectors are I equals 1, 0, so it's 1 unit along the horizontal, the x direction, and 1 unit for the vertical is j. Then the vector r equals ab can be written as r equals a I plus b j. Differentiation and integration is going to be similar to what we've done all the time, so we're just going to say piece by piece dr dt is going to equal, when we have r as f of t times I and g of t times j, we'll take the derivative of f with respect to t, and that'll be our I horizontal component, and then the vertical component will be dg dt times j. And as integration, we'll look at a to b of r of t dt, and we can integrate each part. So we'll say the integral from a to b of f of t dt times I plus the integral from a to b of g of t dt, and then j. Velocity and speed, r is going to be our position, so the velocity vector is going to be the derivative of it. So we'll have dr dt. And then the speed is going to be, just like before, the magnitude of the velocity vector. And the unit vector, which is the direction of motion, so it's a unit length of 1 and it's going in the direction we want, and it's the same as we had before, so it's v over the magnitude of v. And then the acceleration vector, we can write this a couple ways, right? Just like we've done all year round, all year long. We have dv dt, or we can write it as the second derivative of r with respect to time. All right, let's do a couple problems and see how this goes. The main thing for this lesson is just to get used to the notation, because really it's the same thing we've been doing. So first we'll find vector AB. So we're going, but instead of writing it in the kind of the greater than, less than symbols, we're just going to use I and j. So we'll just say the 5 minus the -3 and get 8 I, and then -6 minus 4, -10j. And similarly, we're going to do the same thing for CD, and we get 1 minus 7, -6i, and then plus 2j. And now we're going to add those together. So we have the 8 plus -6, 2i, and then minus 8j, and subtract them. Again, 8 minus -6, so it's 14i, and then -10 minus 2, -12j. So for number 2, when you see these in bold like this, that's telling you that these are vectors. So we're going to go 3u minus v, and we'll have 3 times the x direction, or the I component of the u vector, minus the j component, or the I component of the v vector, sorry, and we get -2, and all of that will be the I. And then I'm going to go ahead and move that minus and just deal with it as plus. So I'll have, again, 3 times the j component this time, and I'm going to say that minus the +1, so I'll have -1 j, and then all you're doing is simplify that, so 17i minus 10j. All right, let's do the next one. So for this one, we're given the position r equals this, and at t equals pi over 3, find the equation of the tangent of the line that's tangent and normal. So we just need to go through our process just like normal. V of t is equal to dr dt. So take the derivative for cosine of t, I, and then bring down that 3, so we have 6e to the 3t j. Let's go ahead and plug it in. Cosine pi over 3 is a half, so we have 2i plus 6e to the pi j. Now this is going to give us what we need for slope, right? Because we're going to say the y over the x part. We're also, well, we can do that right now. So the slope will equal 6e to the pi over 2, which will give us 3e to the pi. Now we need a point, so we'll need r of pi over 3. So just plug that in. 4 times 3, root 3 over 2, so we'll get 2 root 3 I. Especially when there's a radical there, it's better to put it in parentheses to make sure that's clear. And then j. And so just for consistency. Now we'll go the tan line, tangent line. We have our slope and we have a point. Here is the y coordinate of the point, here is the x coordinate of the point. So we just need to plug the stuff in. Y minus 2e to the pi equals 3e to the pi times the quantity of x minus 2 root 3. Or we can move that 2e to the pi to the other side and recall what is this, because we haven't been talking about this for a while. That's right, it's a first order Taylor polynomial. Now we're going to do the normal line. All the work's been done, we just need to plug this stuff in. We have the same point, 2e to the pi, and now we do opposite and reciprocal, so negative 1 over 3e to the pi times the quantity of x minus 2 root 3. And so we're doing the exact same things. Let's continue on going to the backside. Number 4, r of t equals 5 sine ti plus 4 cosine tj at t equals 2 pi over 3. Draw the graph of the particle. So go ahead and set up your xy axis and sketch this. We can see that the max and the min for the horizontal direction will be 5, negative 5, and in the vertical direction will be 4 and negative 4. So this graph is an ellipse starting at the 0, 4 if t is 0. Now we need to find the velocity and the acceleration. So let's just go through that. V of t equals dr dt. And take the derivative of each part. Derivative of 5 sine would be 5 cosine of t times I minus 4 sine of t times j. Go ahead and plug in pi over 2 pi over 3 and get, it's going to be a negative 1/2, so we'll have negative 5 over 2 I. Now one of the things, take the opportunity to refresh yourself on your trig. There's a lot going on here, and especially since this square root here and then you have j afterwards, it's better for clarity's sake to put it in parentheses. We'll need to do a of t, so the derivative of 5 cosine would be negative 5 sine of t times I, and then the derivative of negative 4 sine would be negative 4 cosine times j. Now we also need to draw each on the graph, and also let's find what r of 2 pi over 3 is. And that'll give us 5 times root 3 over 2 I minus 2j. And as we'd expect, if this is starting at 0, 2 pi over 3 should take us into the next quadrant, and it does. We have kind of a bigger x value and a smaller y, So we're looking at something like this. That's R. Now we need to graph what V is. I'll make that one look a little bit better. And this says that both the X and the Y components are pointing in the negative direction. So they're both pointing down like that. So what it is it's traveling along the path of, but it's going it's going off of the ellipse, the path of it. And now we'll find A of pi over 3. So just plugging that in, negative 5 root 3 over 2. And if I put this I kind of in the middle of fraction, it's clear that it's not on the inside, plus 2j. Now compare that vector to the position one. It's in the exact opposite direction. So what it's doing is it's going backwards There we go. That is A. All right. Now let's go to the part C. Find the speed. We already know speed is the magnitude of our velocity, and we're doing this at 2 pi over 3. So it's just the square root of negative 5 over 2, so 25 fourths, and then plus 12. Combine those together, 48/25, and we'll get square root of 73 over 4, or square root of 73 over 2. Now, the direction of motion, as we wrote on the other side, is just our unit vector in the direction. Unit vector just says it's of length 1, so it tells us where it's pointing. So it's just looking at the v over its speed, v over its magnitude. So we'll have negative 5 halves I over root 73 over 2 minus 2 root 3 over root 73 over 2 j. Simplify that to negative 5 over root 73 I, and then minus 4 root 3 over root 73 j. And that's it for that one. Let's go on to number 5. I think you'll find these kind to be pretty simple, because all we're doing is when we integrate the entire vector, you're going to integrate each part by itself. So we'll have the integral from 4 to 5 of cosine of pi over 2t dt, and that is our I component, and the exact same thing, integral 4 to 5 of 2 over t minus 6 dt j. So we integrate each one of those separately. Let's see, we know it's going to be sine of pi over 2. The derivative will give us pi over 2, so we need to counteract it. 2 over pi sine pi over 2t. Evaluate it from 4 to 5, and then that's our I part, minus 2, take that out, and then we'll have natural log of t minus 6, evaluated from 4 to 5, and that's our j part. If you forgot your absolute value, this would help you to remind you of it, because that'll give us a negative number, and you know that's not possible. So to have ln of that. Now we have 2 over pi times, plug it in, it's equivalent to pi over 2, so that's 1, and then 2 pi would be 0. I, so the I component will be 2 over pi, and then minus ln of 1 will be 0, minus the ln of 2, j, so plus 2 ln of 2, j. And then So that's a definite integral, and now we have an indefinite integral, so we have to do it, same idea, piece by piece. We'll have secant of t dt I minus the integral of 1 over t squared plus 9 dt j. So we just need to integrate those. If you don't remember, we can rederive it, but I'm just going to write it down. ln of secant t plus tangent t, absolute value of that, and we have a constant there, c1. And we need to have that, and then we'll say I. Now we need to integrate this one. I'm going to do this over the side. I'm going to factor out that 9. Hopefully we recognize that it is looking like an inverse tan. So I have 1 over t squared over 9 plus 1 dt. And then that can be written as t over 3. And I'm going to try it on this one. I know some still don't like it, but if this were the u, the derivative of it would be 1/3. So what I'm going to do is I'm going to put in a 1/3 here, and then I'm going to counteract it. So now I have that idea of 1 over u squared plus 1. That's our inverse tangent. So this will give us 1/3 inverse tangent of t over 3 plus some constant c2. So all we do is bring that over here, write it, minus 1/3 inverse tangent of t over 3 plus c2, put all of that as our j component, and that's it. The last one, we're going to need a lot of room. There's quite a bit going on this one. So we're given the second derivative of the position, and we have to solve the initial value. Basically, we need to find what the position vector is going to be. So the integral of the second derivative of r with respect to t equals the integral of dv dt with respect to t. So that's going to be the integral of 12t I minus j, and all that's in parentheses dt. So go and do each piece separately. The antiderivative 12t would be 6t squared plus some constant c1 I minus t, put that minus in there, plus c2 j. Now we need to solve the initial. We need to use, remember, use the initial condition. What is that initial condition? We're told that dr dt equals negative j. So that's giving us the vector 0, -1. So plug it in, and we also know that t equals 0. Plug them in, we'll get 6 times 0 plus c1 equals 0. c1 is 0. Then negative of 0 plus c2 equals -1. c2 equals -1. That gives us now our v vector, and we can just go and write r equals dr dt, and we just found that, so we'll have 6t squared I plus -t minus 1 j dt. Integrate each piece again, so we'll have r equals 2t cubed plus c3 I. Remember, we're going to keep on using different constants because they are different constant names. So negative t squared over 2 minus t plus c sub 4 j. This time at t equals 0, we're given that we have the vector of r of 0 equals 2, negative 4. So plug in 0 plus c3 is going to equal 2, c3 equals 2. 0 minus 0 plus c4 equals negative 4. c4 equals negative 4. And now we just write the answer. R of t equals 2t cubed plus 2. That's our I component. And then I'm going to factor out the negative because they're all negative. I could have done that earlier, but you would just have to be careful about using the initial condition. Plus 4j. And that's it. I could leave that negative inside there. Sorry. Inside this part right here, the j component, I could factor it out. It doesn't make any difference at all. And that is our last one.